Alright, guys, today we're going to be talking about polynomial and rational functions. It's the first lesson in chapter 2, and first lesson is going to be on quadratic functions. Now, first, let's talk about just in general polynomial functions, what a polynomial function is. Polynomial function has the form f of x equals a sub n x to the n, blah, 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 blah. You see all this stuff right here. Basically, what that really means is that a polynomial function is a function with just x's that have coefficients in front of them, and x's are raised to exponents. All right. The key though is that n. Remember, n is that's the highest exponent. The highest exponent is a non-negative integer, so the highest exponent has to be 1, 2, 3, 4, 5, something like that. And every a is a real number, so all these coefficients are real numbers. So, for example, a polynomial might be something like this. You could have x to the fifth minus 3x to the fourth plus 2x to the third minus x squared plus x minus 4. And maybe there's a number out front too, 4x to the fifth. Okay, so that's just an example of a polynomial. As long as your terms are like that, okay, all of them have a coefficient, an x, and an exponent. The exponents are, the highest one is a non-negative integer, 5. Of course, that's a positive integer. And all the coefficients, the numbers in front of x's, are real numbers. So that's a polynomial function. Now, a couple of specific polynomial functions. We have a constant polynomial function with degree 0. It's just a polynomial function with degree 0. So here's what one would look like. F of x equals a. Where a is a real number. So it's just f of x equals 5. Okay, so that's a constant function. And that graph, as you know, is just a horizontal line on the graph. Linear function. So now we add on a term to the original, right? So before we had a, now we still have that constant term, but now we add on a linear term that has an x to the first. Okay, so when we talk about degree, we're talking about what is x raised to. So the first one, the constant function is degree 0. X is being raised to the 0 because there are no x's. In a linear function, x, of course, is raised to the first. So that's degree 1. Right, a and b got to be real, and a can't be 0. Because if a is 0, well now 0 times x is 0, and it's just a constant function again. There is no x. So that situation can't be 0. Okay, so that brings us to the function topic we'll talk about in this lesson, quadratic functions. Just a polynomial function with degree 2. Degree again means the highest exponent is 2. So you can see now we just took a linear function and added on this term right here, an ax squared. Okay, so that's a quadratic function. Okay, so let's look at comparing some quadratic functions to their parent function. Okay, example 1 says sketch the graph of the function, describe how the graph is related to the parent function. So a couple ways you can sketch it. You can just plug in values for x and have it spit out the y values and graph those. Or you can graph it by your knowledge of the parent function. All right, so the parent function we know is gonna be 0, and then you go over 1, go up 1 because it's 1 squared is 1. 2 squared is 4, so we go over 2, 4. And then 3, we would go up to 9 somewhere way up here. And of course, it's reflected across on the other side. All right, so this would be the parent function of g of x, the y equals x squared function. Okay, so we can just do what we know about shifts, translations, and say, okay, the negative's going to make it flip across the x-axis, and we're going to raise it up 1. So this point right here at 0, 0 is going to flip. So it's just going to stay in the same spot it's in because it's flipping over the x-axis, and it's already on the x-axis. And then we're going to add 1, which moves everything up 1. All right, the point 1, 1 is going to flip, so it'll be down at 1, negative 1, but then we shift it up 1. Same thing with the other point. Okay, and you can see this other point 2, 4 is going to be at 2, negative 4, but then we shift it up 1. And the point negative 2, 4 is going to be down at negative 2, negative 4, but we shift it up 1. And so on and so on. So eventually you'll keep going and you get your other points and you get that graph. Okay, so that would be the graph of negative x squared plus 1. Another way you could do it is just to plug in values straight in for x, plug in 0 right there, 0 squared is 0, times negative is 0, add 1 is 1. So 0, 1 would be a point. Okay, so either way is fine, whichever way works for you. Okay, and we want to describe how that's related to the parent function. So the way that's related is it flips over the x-axis. We say reflect over x-axis and shift up 1. Okay, so that'll work. All right, the next one, h of x, is going to move the parent function left 2. So we can go ahead and say what we're doing. We're going to shift it left 2. And down 3. Because the plus 2 moves everything left 2. So we're going to move the point 0, 0, left 2, and down 1, 2, 3. So right there. Our point 1, 1 will go left 2 and down 1, 2, 3. And negative 1, 1 will go left 2 and down 1, 2, 3. 2, 4 goes left 2 and down 1, 2, 3. Negative 2, 4 goes left 2 and down 1, 2, 3. And you can do another one, 3, 9 if you want, left 2 and down 1, 2, 3. And the other one, of course, would be out here. All right. So those are a couple of examples like that you would do to describe the function. So go ahead and pause the video and try the one at the bottom of the slide on your own. All right, so here's the function you should have graphed for j of x. You flip it across the x-axis. It's not right. Flip it over the x-axis, and then we go left 3 and down 4. Alright, let's roll on. Okay, identifying the vertex of a quadratic function. So this process we're going to use completing the square to do this. We want to describe the graph of this function and identify the vertex. So first of all, let's put it in vertex form. So the step to do that, or the way we do that, is by completing the square. So first step is to group the terms with the x's together. So I'm going to group the two terms with x's together. And now next we want to do what's called completing the square. So to do that, you're going to take half of the number that's in front of x, which is 8. So we take half of that. Well, that's 4, right? Actually, first, before you do that, you need to factor out anything that you can factor out of that term. So we can factor a 2 out. So we need to factor a 2 out from 2 and 8. So we take out a 2. That leaves x squared plus 4x. Okay, now we want to complete the square. So we're going to take half of the number in front of x at this point. Make sure you factor out a number if you can take a number out of both terms. So now we take half of 4, which is 2, and square it. Okay? So you're always going to, I'm going to come over here, you're always going to take half of it and then square it, whatever that number is in front of x. Alright? So we take half of that and square it. We're going to add it in. So 4 divided by 2 is 2, and 2 squared is 4. We're going to add it in and subtract it. Alright, and then leave your plus 7 out here. Alright, now we're going to group the first 3 terms together and bring the minus 4 out. So if we group the first 3 terms together, we would have this situation right here. Okay, and we're going to put those in parentheses. But notice the 2 in the step above was going to be distributed to all 4 of the terms, including the minus 4. So at this point, we're still going to distribute the 2 to these first 3, but outside the parentheses, we need to write minus and distribute the 2 to the minus 4 right here. Give that 2 to the minus 4, and then put your plus 7. Alright, so now the only thing left to do is basically factor x squared plus 4x plus 4. So remember how we talked about the quick way to square a binomial? Remember if we took like x plus 3 squared, we would square x and we would square 3, and then we multiply them together and double it to get the middle. Well, we're doing the reverse right here. We're taking something that looks like this and going back to an expression that looks like a binomial squared. So the way you know what your binomial squared is by just doing half of that middle term again. So just like we did half of it before and squared it, we're going to take half of it now. And that's the number that we'll put right here at the end of our binomial. So we got 2x plus half of 4 is 2. And now we can put a squared. And then outside we've got 2 times 4 is 8. So we got negative 8 plus 7, which is minus 1. Alright, so this form that we're in now is called vertex form. Okay, because in this form you can see in the formula your vertex. Our vertex comes from these two numbers right here. Alright, you use the opposite of the number in the parentheses, negative 2, and use the number on the outside, negative 1. So the x-coordinate is negative 2, and the y-coordinate of the vertex is negative 1. Now, again, the vertex is the point at the bottom or top of your parabola, that very, very bottom point, the minimum or the maximum, however you want to think about it. Okay, so now we've identified the vertex. Our vertex is negative 2, negative 1, and if we want to describe the graph, so we know it's going to be a parabola, okay, so we can say a parabola that opens up. Now, how do we know it opens up? You know it opens up based off the number in front of the parentheses. Okay, so this number right here. If it's positive, it opens up. If it's negative, it opens down. We know that because we know the negative flips the graph. So when it has to describe the graph, we just need to determine does it open up or down. So we've got a parabola that opens up because it's a positive number out front, and it's got a vertex at negative 2, negative 1. So I'm going to pause the video again. You guys pause yours and give the next problem a try. Let me know if you have questions. I'll come around and help. Alright, so right here we've got f of x equals x squared minus 8x plus 16. So first we want to group the x terms together and factor out a number. Well, this one doesn't have a number to factor out because there's no coefficient in front of x squared. So we just leave it like that. And then we're going to complete the square, right, by taking half of 8. Okay, so we take half of 8 and we square it. Half of 8 is 4, and 4 squared is 16. So we're going to add in 16 and subtract 16. I always do the add 16 first. And then at the end, remember we've got the plus 16 on the outside from the original formula right here. Okay, so now we're going to regroup the first three terms together. So we've got x squared minus 8x plus 16. And then we bring the minus 16 out of the parentheses and add the 16. And at this point is when we combine this back into a binomial. So we've got x, and remember the number we put at the end is half of 8. So half of 8 is 4. Of course it's minus because it's a minus 8. We square that and then combine the stuff on the outside. Minus 16 and 16 just cancel. So f of x equals x minus 4 squared. Alright, so to describe this parabola, well, it's a parabola that opens how? Well, the number in front of the parentheses is positive, so it's going to open up with a vertex at, remember, use the opposite of the sign on the inside, so positive 4, and use the number that's added on the outside, 0. So this parabola has a vertex at 4, 0. Alright, let's roll on. Okay, so now we want to look at how to identify x-intercepts of the quadratic function. Alright, so we've got our function here, f of x equals negative x squared plus 6x minus 8. And essentially right here what we're going to do is factor, if you guys remember how to factor. So before you can factor into binomials, you need to take away this negative from everything. So we've got to factor out this negative as a greatest common factor. So take out a negative, in parentheses, what does that do? It changes the sign on everything. So every term is going to have a different sign. We're going to have positive x squared. We take out a negative from positive 6x, it makes it negative 6x. We take a negative away from negative 8, it makes it positive 8. So now at this point, we're going to factor this trinomial And you might have learned different ways to do it. One way that I have always taught students that helps is to make an X. I call it the X box method. So you always put this number in the top, put the sign in front of it right here in the middle, and then you put the next number, ignoring that sign. Don't put a negative, just put that sign at the bottom. So the question is, what two numbers will add up, or will multiply to give me 8 and add up to give me 6? Okay, so that's how you can think about it once you get it written in there. What multiplies to be 8 and adds up, does that sign to give you 6? If that sign was a minus that we put in the middle of the X box, then we would say what multiplies to be 8 and subtracts to give me 6. So the two numbers that multiply to be 8 and add up to 6 are obviously 4 and 2. So then right here, those are the numbers that we're going to use in our new binomials. Or maybe we'll calibrate the board real quick. Not sure why that popped up. All right. So we're going to write the numbers 2 and 4 each in a binomial with x. We put x in each one of them, put a 2 and a 4 in the front. All right, now the way you know what sign to use on each thing depends on the signs in the original formula. So when this is a plus, okay, the sign on the left is the sign I'm going to use. So this sign's the sign I'm going to use, and this sign tells me how many times to use it. A plus means use it twice. If it was a minus, I would just use it once. So I'm going to use a minus on both of them. If it was a minus minus, that means use a minus one time. If it was a plus minus, that means use a plus one time. If you can only use it once, you put it on the bigger number. All right, of course, if it was a plus and a plus, that means use a plus on both, because I use a plus on 2. And if it's a minus and a plus, like it is in this situation, then we would use a minus twice. Okay, so that's a trick for me to remember. If you've got a different way that you learned to do it that works for you, that's fine. But if you like this way, feel free to use it. Okay, so now we've got our function negative x minus 4 times x minus 2. So to find the x-intercepts now, you just need to set each of these factors equal to 0. So I'm going to say x minus 4 equals 0 and x minus 2 equals 0 and solve it. So we add 4, x equals 4, add 2, x equals 2. So those are our two x-intercepts of the function. Okay, and if we wanted to describe the graph, we could go through the process we did on example 2 by factoring or completing the square and finding the vertex and seeing if it's going to open up or down, all that good stuff. So obviously this one's going to open down, so we can at least say it's a parabola that opens down. If you wanted to describe it by using the vertex, you need to get it in vertex form like we did on example 2. Alright, so let's let you guys try to do that on this part right here. Pause the video and give it a try, and I'll go over it. So right here you can see we did our X box. We said what multiplies to be 3 and subtracts to give me 2. Alright, what multiplies to be 3 and subtracts to give me 2. So I put 3 minus and a 2 right here. And I realized that those two numbers were 3 and 1. So I put those in my binomials with 3 and 1. To determine the signs, I'll look at the signs of the original. I'm going to use a plus sign just once. If I can only use it once, then I use it on whichever one of these numbers is bigger. Okay, so I'm going to put the plus sign on the bigger number, which is 3. That means that the 1 has to have a minus. If I can only use it once, the other one's got to be the other sign. Then I can set each of those equal to 0, subtract 3, x equals negative 3, and add 1, x equals 1. So my two x-intercepts, remember x-intercepts are where the graph is going to cross the x-axis. Okay, so this is going to cross at negative 3 somewhere and at positive 1. It's going to look like a parabola like that because I see that it opens up down because of the minus in the beginning of the function. All right, let's roll on. Let's got a couple more examples. So right here we're actually going to write the function. We want to write the vertex form of the equation of the parabola. Its vertex is at 1, 2 and passes through the point 3, negative 6. Okay, so you got to remember how vertex form is structured. So I'm going to write it up here, y equals a times x minus h squared plus k, where hk is your vertex. Okay, that's your vertex. So if we know our vertex is 1, 2, right, that is our h and k. So we're going to plug those in to that formula right there. All right, so we say y equals a times x minus h, so minus 1 squared, plus k, so plus 2. All right, now the problem is we need to figure out what is a. We're good with everything else except a's got to be some kind of number. So we're going to use this other point, plug those in for x and y, and then we can solve for a. So to plug in y is negative 6 equals, a is still a variable because we're trying to solve for it, x is 3. So now we can multiply all this out, subtract it, all that stuff, and solve for a. 3 minus 1 is 2. So we've got a times 2 squared plus 2. 2 squared is 4. So 4a plus 2 equals negative 6. And then we subtract 2, so we get negative 8 equals 4a. And we divide 4, so that means a's got to be negative 2. Right, so now once I know a, again, the problem is to write the vertex form. So now I'm going to plug my a back in and write the vertex form. So negative 2 times x minus 1 squared plus 2. I'm just going to take it and put it back in right here and write this exact thing, only plug in the value for a that I found. So when I do that, right here's my answer. So that's the function that has a vertex at 1, 2 and goes through the point 3, negative 6. All right, go ahead and try the one down here on your own. I'll pause the video and y'all can give it a try. Okay, so in this problem, we're going to do the same thing we just did an example of. So let's plug in the vertex, remember, is h and k. So we'll say y equals a times x minus 2, really makes it a plus 2. Don't forget your square and then add k, so add 5. Alright, so now we need to figure out what is a. So we're going to plug in 0 and 9 for x and y. So y is going to be 9 equals a times x will make 0 plus 2 squared plus 5. 0 plus 2 is 2, and 2 squared is 4. So we got 4 times a is 4a. 4a plus 5 is 9. Subtract 5, and we got 4a equals 4. Divide 4, so a equals 1. Right, then once you know a, you're going to take it and plug it back in to your vertex form for a. So our function is going to be f of x equals 1 times x plus 2 squared plus 5. And of course, since we're multiplying by 1, we don't really need the 1. 1 times anything is just itself. So we can just put x plus 2 squared plus 5. So here's the function with the vertex at negative 2, 5. It'll go through the point 0, 9. The only last problem we need to do now is one that's a real world problem. So we've got a baseball that's hit at a point 3 feet above the ground at a velocity of 100 feet per second and an angle 45 degrees with respect to the ground. Path of the baseball is given by this function, which you can see is a quadratic because it has an x squared in it. It says f of x is the height of the baseball in feet. So our y value is the height, and x is the horizontal distance from home plate. So how far the ball is away from home plate. So if the fence is 300 feet, then we would need for x to be at least 300 in order to hit a home run, because we need to know how far from the home plate is x. We want to know what is the maximum height reached by the baseball, and how far from the batter does the ball hit the ground. So how far does the hit go? Okay, so let's use our calculator right here. Let's graph the function. So go to y equals, and let's graph negative 0.0032 x squared plus x plus 3. And we graph it. Now when we graph it, it looks like just a straight line. So sometimes this will happen. You just need to zoom out until you can see more of the graph. So hit zoom, zoom 3, and hit enter. It won't zoom until you hit enter. We zoom out, well, it still kind of looks like a straight line. Maybe it looks like it's curving a little bit, but we still need to see more of the graph. Just hit enter again, and it'll zoom out another time. All right, so now we can see the curve. Maybe zoom out one more so we can see the maximum. If you zoom out and it's too far, then you might want to just zoom back in. So now we can see a good parabola right here. And the whole point, remember, is to find what is the maximum height. Okay, so we need to find the maximum right here. What is the highest point the ball reaches? So to find the maximum, we know how to do that. We'll hit second calculate and pick 4 for maximum. Left bound, make sure the cursor's to the left of the maximum. Hit enter. Now move it over to the right side of the maximum and hit enter. And it says guess it, enter one more time. Okay, so we get that y, remember y is f of x, which is the height of the baseball. So when it asks what's the maximum height reached, well, the maximum height is the y value, 81.125. And the x value is the horizontal distance from home plate, so the distance that it is away from the plate. And so when it says how far does from the batter does the ball hit the ground, x is our answer. That's how many feet the ball traveled in the air. So what we would say for our answer is the first question, the maximum height reached would be 81.125 feet. Okay, or if you want to round it off to something, you can. 81 feet is fine. And then the distance that the ball traveled from the batter is 156.25 feet. All right. So appreciate your all's time today. Let me know if you have any questions on any of this. And here is your assignment, so you can go ahead and practice some of this stuff. Let me know if you have questions.